All right, 2.1 conditional statements. So first off, a conditional statement, it can be anything. It doesn't necessarily have to apply for math, but it's often in the form if-then form. Okay, so if this happens, then this happens. The if part is what we call the hypothesis. Okay, the if part is the hypothesis, and if that happens, then the then part is what we can conclude. Okay, so for example, if the Burrows play tonight, then they will win. So that is a if-then statement. It's got a condition. The condition is if the Burrows play tonight. Well, if the Burrows don't play tonight, can we conclude they win? No. The only way the hypothesis can be, or the conclusion can be made, is if the if part is satisfied. So if the Burrows play tonight, there's the hypothesis, then they will win. There's my conclusion. Okay, so the hypothesis in red, conclusion in green. So moving on here. Here's a couple examples. What we're going to be doing today. It seems like a lot of writing. Okay, it's not what you normally do in math, but we're going to be doing a lot of writing. So we can take a statement and rewrite it into if-then form. So this is still a conditional statement. You have to have the number being divisible by 9. So a number divisible by 9 is also divisible by 3. There's the conclusion. So I'm going to rewrite this, and I'm going to say if a number is divisible by 9, if it's divisible by 9, then it is also divisible by 3. So I took a statement that was not an if-then form, and I rewrote it into if-then form. This one could be, this one's a real simple statement. All mammals breathe oxygen. We can do this the same way. We might have to add some extra words in. So you might want to say, like, if a species, a mammal, let me think here. If an animal is a mammal, then it breathes oxygen. So if an animal is a mammal, then it breathes oxygen. Okay, so you might have to add into it. Now, are all these statements necessarily true? No, they could be. You could have a conditional statement that's not true. For example, if a number is odd, then it is divisible by 3. Well, that's not a true statement. It's still a conditional, an if-then conditional statement. What we want to do is we want to find a counterexample to show that that is not true. Okay, so if a number is odd, I could pick an odd number, 9. Then is it divisible by 3? Well, 9 is divisible by 3. So that is not a counterexample. That shows the statement is true. To show the statement is false, all we need is one example that would show it. So for example, I could say 7. 7 is an odd number. It satisfies the hypothesis, but is it divisible by 3? So it is not. So a counterexample would be, get rid of that. 7 is odd, but not divisible by 3. Okay. Here's another one. If x squared equals 16, then x equals 4. Okay, so a lot of people would look at that and say, well, x could be 4. 4 squared is 16. That seems like a true statement. But is there anything else? Does it have to be x equals 4, or could I conclude something else? And if you think about this one, x could also be a negative 4. So a counterexample would be if so if x squared equals 16, then x could equal negative 4. Some more vocabulary words. You want to make sure you get these into your notes, because we will be using them quite a bit. Get rid of that and bring these down. You'll be using these quite a bit. Okay, the converse is where you switch your hypothesis and conclusion around. So instead of if your hypothesis, you're going to say if your conclusion, what you conclude. So for example, if we went back to the Burrows game, if the Burrows win tonight, then they played. It doesn't quite make sense, but you could tweak it a little bit to make it work better. The inverse would be you just negate the hypothesis. So if the Burrows did not play tonight,
There is a staffing in Mr. Gladys's room at this time.
If the Burrows did not play tonight, then they did not win. And the contrapositive, you're going to negate the converse. So we're going to switch it and negate it. Okay, negate means to make it negative. So if the Burrows did not win tonight, then they did not play. Okay, we'll try to hurry up here. Here's a list of a bunch of postulates. You'll want to read through these, kind of make sure you understand them a little bit. You can hit pause and write them into your notes if you want. Remember, a postulate is just kind of an accepted statement. In other types of geometries, they'll throw out some of these postulates, and you get a whole different set of rules. But these are the ones we go with in Euclidean geometry, and you'll need these for from here, write the inverse, the converse, and contrapositive of postulate 6. All right, so here's the inverse, A. You remember, so here's the original statement. Line containing at least 2 points. Line contains at least 2 points. So I gotta get my pen out again. Sorry. So A. Inverse. So remember, inverse is where you negate it. So so if I want to say not a line, so I'm going to say the inverse if a figure is not a line, then it does not contain hold on, at least 2 points. I gotta think, because not containing 2 points might not necessarily be the same as at least 2 points. Well, so if it does not contain at least 2 points, yeah, that should work. Just have to think about it for a second. There's nothing wrong with not being able to do these things right away. It takes some time to make them work and be good. we go to B here, the converse, remember, is where we flip it. Um, all right, sorry about that. Hopefully I took care of it this time. So converse is where you flip the order, you go back and forth. All right, got interrupted again, but hopefully we can just start going. So converse, I got to flip the order of the hypothesis and conclusion. So if a figure contains at least 2 points, then it is a line. And now C, the contrapositive, is where we both do both the converse and the inverse. So the converse, we flip the order. Inverse, we negate the statement. So it's going to be start off the same as in B. If a figure, but now we got to negate it. So the figure does not contain at least figure contains at does not contain. Let's get rid of that. 2 points. Then it is not a line. Okay, so once again, inverse, you negate the hypothesis and negate the conclusion. Converse, you switch the hypothesis and conclusion. And the contrapositive, you do both. You negate it and flip hypothesis and conclusion. Um, so so that's the end of the lesson. You get to work on this homework assignment in class tomorrow, and you get to ask me questions. So hopefully this will give you a lot of time to work. If you need to, go back through any examples and watch them again. Have a good night.